Well, good morning. I'm Ken Biberaj, and welcome to Coffee with Ken, a thought leadership series at the nexus of business, politics, and food safety. Today, we're welcoming an exciting panel for a discussion around innovations in food safety. So pleased to be joined by Jen McEntire, the founder of Food Safety Strategy, Adam Saltman, the Chief Medical Officer of HyperSpectral, and Matt Theurer, the co-founder, president of HyperSpectral. Good to see you all. How are you?
Great.
Doing
Good.
well. Thank you
How
for
are you?
asking.
Well, I haven't eaten anything today. I just want to make sure we have this conversation and I can see what's safe to eat and digest. But Jen, I'd love to start with you. First of all, great seeing you all post Thanksgiving. And it's one of these things. I got three kids. I make lunch for them every day, and they got the little compartment of three things for sides, and I usually put my baby carrots in there and my little cucumbers, and both of those have been recalled in the last like 10 days. So I'm running out of options, Jen. What's going on? Are we having more recalls than ever? And how does this system work in even identifying when we recall food?
Sure. So first, thanks
No
for
pressure.
having me.
It's just, my kids and, their lunches.
And it's food is personal, right? We all have to eat. You don't have a choice. And so food safety is really important because food shouldn't be making people sick. And there's a lot of work that goes into making sure that food is safe. But as we've seen, as you mentioned over these past few weeks, sometimes the systems aren't perfect and things get through. And then we have these recalls. At the worst, we have outbreaks, and it requires people to actually seek medical attention to understand that there may be an outbreak brewing, and a lot of work that the federal agencies, state and local health departments do to trace food back to try to figure out what's making people sick, working with those companies that have been identified to pull that food out of the supply chain, hopefully in time. Usually takes a while before we realize there is an issue. And with fresh produce, you mentioned baby carrots, you mentioned cucumbers. These are highly perishable items. And so usually by the time an issue is recognized, that product is past its shelf life. And we have seen that with some of these produce related recalls. And so I hope that your kids will continue to eat baby carrots and cucumbers and other really healthful food products,
Yeah.
Knowing that the industry is working hard to make sure that every day with all the people all around the world who are eating food, that food is produced safely. But is there more work that we can do to make food safer, to ensure that it is safe, to give consumers confidence? Because when you're talking about your kids, you don't want to inadvertently feed your kids something that might hurt them. So there is more work to be done, and I look forward to talking about this stuff because I like food and I love food safety, and I'm so glad that it's part of the conversation.
Well, no one loves food safety more than Adam Saltman. So I'm excited to kind of have you both here. I mean, Adam, your perspective is so unique in this, right? You were in government and now in industry. Talk a little bit about that, like how your career has kind of informed what you're working on now.
Yeah, I mean, so I started out as a surgeon and then I went to FDA for about 12 years. And now I've been working with small startup companies and now HyperSpectral. It's really trying to essentially move the needle in the way patients are cared for, right? So, the concept of picking up contaminated food before it's ingested is incredible, right? The fact that you can prevent people from getting sick, but that is immediately transferable to a lot of medical challenges that we face. So, I look at what Jen is doing and, what HyperSpectral is doing in regard to picking up contaminated food, but how about patients who show up in the emergency room sick? And we're trying to figure out what's wrong with them. I mean, can we take this technology and then move it over into the medical space? So, I'm really excited to see this going this way and making things faster, better, less there.
So this effort to kind of connect the dots, obviously, Matt, technology can help with that, right? So when did you kind of realize there was a market opportunity here? What are you trying to fill here?
Sure. So, I am a proud geek at heart, right? And I've spent my career, looking for technologies that I thought were going to really alter things. And oddly, honestly, we were kind of inspired by the pandemic, but a lot of regulatory barriers, right, to dealing with human health. You want that to be a very high hurdle. Um, Food has a slightly less, high regulatory burden to get into. Um, for good or ill, that's just the way it is. But a lot of the pathogens are the same. right? I mean, obviously, if they're in our food and they're causing, causing issues in human health, right? So, you look at, say, E. coli, right? It's a big problem in food. It's a problem in, say, wounds. Correct me if I'm wrong, Adam. But there's a lot of these bacteria go back and forth. So we're like, there's a market with a driving need. We're looking at the recalls, like, wow, there's a lot of food recalls. They seem to be getting worse, right? The numbers seem to be growing. Can we solve this problem? And again, not being blessed with a degree in biology, I'm like, well, let me see if we can solve this with physics, right? And that's what we were looking to do, right? And it's not just the application of physics, right, or spectrometry. Spectral data is what we use. Which doing the research, we found I found a paper from the 1890s, right? Not the 1990s, the 1890s.
Wow.
On using spectroscopy to identify bacteria. So the idea is not new, right? There have been a lot of technological advances in the last 135 years since that paper. I should say 132 years. I think it was 1893. Since that came out, it's that make getting, acquiring spectral data, easier, faster, cheaper. Some of the fundamental problems that existed in the past, still exist, in that lab specimens of bacteria or other substances are very pure, very easy to find. The real world, not so much. I'm sure you can imagine there's a lot of other stuff in a nasal swab, or a lot of other stuff in a swab that comes out of the drain in the food processing facility than just, say, the bacteria you're looking for. So the problem has historically been, how do you find that signal of that presence that indicates the presence of a bacteria within all the other stuff that's there, and that's where artificial intelligence comes in, right? And that's really what makes this possible today, right? Is coupling of artificial intelligence with, again, a very well-known and well-established technology to give it new life to solve problems that we're all facing today, and that's what inspired us.
Just real quick, just to kind of level set on just like how things are done today, Matt. So like, where are we just technologically on food safety kind of technology versus you're talking about AI? I feel like you're already here. Is this like a huge gap, or is it kind of like, are we a little slow to adoption on technology for food safety today, for example?
I'll certainly let Jen weigh in on adoption rates of technology in the world of food safety. I will say that, generally speaking, a lot of the technology that's used in human health is the same technology that's used to find bacteria in food. So you're talking about PCR, lateral flow assays, basically kind of the standards that have existed for the last 20, 30 years, maybe longer. I'm not sure when PCR was invented. Adam, you'd know better than I would. Which involve amplification of DNA or real identification of DNA or RNA, which takes fantastic technology. It's just not the fastest in the world, it's very eminently suitable for take a sample, send it off to a lab. Very complex processes, very expensive, complex equipment, requires highly trained lab techs to do that kind of work. And we're trying to get something down at the edge where you don't need to have a lot of very expensive equipment or highly trained personnel. So again, the existing standard are the same techniques used in human health, things like, again, PCR. And I'll let Jen weigh in on
perfect segue, because I think you alluded to Jen kind of as being a ghostbuster, right? Like, usually something goes wrong and then people call Jen, right? Like, so Jen, when do you dive in? What are your thoughts on this?
Yeah, unfortunately, I do often find myself diving in when things have gone wrong, although I would love to spend more time on the preventive side. But in terms of the way that food safety is managed today, people do put a lot into prevention, and that is where the emphasis should be. But how do you know that your systems are working? Testing is a way to verify that your systems are working. And we also see that testing sometimes shows that systems are not working. But the tests that are done today, especially for bacteria, when they're in food, it's usually at low levels, sporadic contamination. Humans are great incubators. Once we eat that 1 or 2 or 3 cells,
Sure.
we grow them up and then they make people sick. And it's a bit easier to detect from the humans because of the abundance of the bacteria that are there that have resulted in you getting sick. In food, it's a little more hit or miss. It's kind of a needle in a haystack. And so a lot of the testing that's done today, most of the testing for bacteria requires you to grow those bacteria, and it takes time. It takes more than a day often to get adequate numbers that then the methods can detect in terms of sensitivity. So it's a very biological based detection system today for the most part. Yeah, we've moved to some molecular detection, but it's still based on biology.
Yeah.
And so I think looking at ways that we can speed things up, especially when we're talking about the perishable items that move through the supply chain very quickly. Companies don't want to have to hold them for several days waiting for their test result.
Sure.
So how can we make things faster? How can we make things affordable? People complain about food prices. We don't want to be adding a tremendous amount of cost to the system. It hits consumers' pockets.
Yeah.
And so it's a balancing act of how do we optimize food safety? How do we have an efficient food safety system and one that people can trust?
So to talk about the benefits of you engaging with companies earlier than crisis mode, right? Like, what are the steps you kind of help take them through? Is it like an assessment of how they're doing this today and so on?
Yeah, there are regulations in place that govern
Yeah.
food safety. So although they're different compared to the human health industry, food safety is regulated. The enforcement is questionable. And so people like me will come in and really kick the tires on the programs that are in place, at least what's written down on paper. That's a starting point. And then you have to see, are people implementing this every single day for every single batch? And the rigor that's required to do it perfectly all the time is pretty tremendous. So it's making sure that your system is set up right. Again, testing can help verify that what you think is working is actually working, or maybe it's not working. But then the execution, the implementation is always a challenge. People aren't perfect and systems aren't perfect. But I try to work with companies to make sure that they are making good use of their resources, that they're not spending time on things that aren't really going to matter so much, that they're putting their resources toward those systems that are really going to be protective.
Interesting. Adam, I'd love to kind of get you're good. I'd love to
Yeah,
get your feedback on this. Yeah.
well, I think you've touched on some interesting points, both Jen and Matt, which is that the word that I'm coming up with is availability. And so when you're talking about tests that are expensive or might require special training or special labs, that is a lack of availability where it's really needed. And so the idea of using spectroscopy and an artificial intelligence algorithm, which, I mean, the hardware and the software have gotten to the point now where these can be made much more available at the point of care or at the point of service. And so, you could put this in physicians' offices or clinics or patients' homes or wherever you first encounter whatever it is you want to test. And so that makes it a lot more, it democratizes it, right? And it also it may be an upfront cost, but it decreases the cost of the overall system operating. Because if it picks these things up before people ingest them or before they become a clinical problem, now you save the system money. Matt mentioned wounds before, and indeed we are looking into scanning wounds and finding bacteria in wounds. More than $2 billion a year are spent on chronic wound care. So,
wow.
right. So if we could take a piece out of that and decrease, the cost of care by stopping patients from getting sick or, having their wounds getting, causing them to get septic or sick, then we certainly could decrease the cost of care of the overall system. One of the other things you pointed out is with artificial intelligence and regulation. And that's something I wanted to dig into for a second, because that right now, from a regulator's point of view, is the Wild West. Nobody has figured out the rules, and they're still working their way through it, both regulators and manufacturers. And so the concept that you have a product that's driven by artificial intelligence, how is it actually doing what it does? How is it actually coming up with a determination that there is or is not something present? Really, we're still trying to figure out how should it be tested? How should it be validated that it does what it says it's doing? And so we're really at the cutting edge of this field.
Yeah,
Fascinating.
that's a great. You mind if I weigh in?
No, please. Yeah.
That's a really. There's 2 points that I kind of love. Just one from Jen and one from Adam. Yeah. So regarding Adam's, that the idea that AI is this black box, right? That something comes in and something comes out.
Yeah.
That's a real. That is actually a very valid concern, depending upon how you develop those artificial intelligence engines. And it's been shown multiple times that you can build unintended biases into artificial intelligence. Yeah. One of the beautiful things about using repeatable scientific data as the basis for your training sets is that it is in and of itself a ground truth, right? Most people do with artificial intelligence algorithms. I mean, at this point, every single one of us has dealt with some form of a generative AI chat, right? Chat GPT or any of the others, which their source of data is basically everything that's on the internet, right? And everything on the internet is true, right?
You said it.
Hopefully the sarcasm didn't drip too much when I made that statement. So there's an inherent issue with those, right? To be perfectly honest, when you're dealing with scientific data, chlorophyll, leaves are green because of chlorophyll, right? It is what it is, right? So a spectral response is the spectral response is the spectral response. Now, there's a certain beauty to be able to have kind of a ground truth, but we work very, very hard to make sure we understand how our AI engines actually interpret the data, right? So we do a lot of work to compare what our models select on to known scientific literature, right? To say, hey, we are selecting this appropriate wavelength, right? That's what the model picks up on, right? Because that's been proven for the last 130 years with spectroscopy in labs, and it matches up with PCR and other known issues. And so, that's something we spend a lot of time validating to make sure that we can explain to regulators in the industry why and how that's working. Jen brought up a really, really good point in that, finding bacteria in the wild if you say in food is like finding a needle in a haystack, right? And we spend a lot of time working on how do we make sure when we take a sample that we're maximizing our opportunity and our chances to pick up that bacterium. Now, we can prove conclusively that we can focus our equipment on a single bacterium and pick up that signal. I mean, the spectral signature that comes out of a single bacterium, say a single Listeria bacterium, is the same whether there's one there or there's a million there, right? We know that. We can pick one up. The hard part, of course, is how do you get that one bacterium in the laser, right? So that the laser picks that up. Yeah. And we've actually made a lot of progress and a lot of work on using some fairly interesting techniques to force all the bacterium into a very confined location so we can pick that up, right? And that's actually a subject of work at not just at HyperSpectral, but at universities around the world, and we collaborate with a lot of them on understanding the techniques that are there. So we've actually just finished a whole series of experiments where we are doing no growing. We're doing no incubation, right? We started off with, let's just mirror PCR,
Sure.
right? Let's grow, right? So that the solution is suitable to go into a food safety lab. Now we've gathered a whole bunch of data where we're doing no incubation whatsoever, and we're actually picking up those signals in very low concentrations with no incubation whatsoever, which will allow us to put the technology out in the field. Because I'm sure Jed, you can confirm or deny this, but I would imagine most food processing locations, don't like the idea of growing bacteria on site. We're working to be able to get this out into the field with no incubation whatsoever, right? So we're really happy. But again, it's all been through a combination of multiple fields, right? I mean, we're a multi-domain solution, so we have microbiologists and MDs and optical physicists and engineers and machine learning people all working together on this problem, right? Because this is not the province of a single domain of expertise to solve this problem.
Yeah. Collectively for the group, I mean, is the effort more focused in general around prevention and detection early, or around traceability and kind of addressing things as it happens, right? I feel like in Europe, Adam, maybe you know a little bit more of this, there's a lot of traceability initiatives and efforts and kind of regulation on that side. So I'm just always kind of curious, like, where is the attention and focus today, just from a regulatory, technological perspective, Matt? And where should it be increased, maybe?
Well, I mean, from my perspective, I think it comes down to what you're trying to do with the specific use case, right? So in some instances, you're trying to detect that something is there. In other instances, you're trying to say it's not there.
Yeah.
And so, there's always a trade-off. Matt mentioned all the machine learning engineers and all the people who are building these artificial intelligence models. How do you make the model work? What are you trying to do? So, for example, in the clinical space, I might say, I want to rule out the presence of like an antibiotic resistant bacteria. That's what I'm trying to do. I don't care about, the other stuff. I just want to rule out the badness. So I would build the product to do that, to be powered to do that. In another, you might be trying to pick up that needle in a haystack. And so you want to be super sensitive at picking up something. So, that's a trade-off, and trying to figure out the use case. That's really where we start, and then build it from there.
Interesting. And Jen, talk to us a little bit about kind of challenges to adoption or increased investment, right? Is industry supportive of more technological investment and activity? Are regulators, right? Like, where are the kind of roadblocks or kind of, speed bumps?
Well, from the standpoint of regulations, for most of the food industry, testing is not, strictly speaking, required.
Yeah.
It's pretty rare. There are a couple of products where testing is required, but for most of the industry, it's not. That said, buyers, the big food service brands, big retailers, they have a brand that they need to protect, and they want to make sure their food is safe. And so for those products that have had a history of outbreaks and recalls, those buyers exert a lot of influence in the supply chain. Even if regulators don't have the regulatory stick, buyers can still say, if you don't do XYZ, I'm just not going to be able to buy from you. And sometimes testing is a part of that. So that's one driver. Another driver is that companies, as we see better outbreak detection systems, we know that people are getting sick. We are getting better at connecting the dots of human foodborne illness. We're getting better at traceability. In the past, I think we were missing a lot of stuff. Illnesses were happening, but we weren't as able to figure out what foods were the cause. Today we can. And so that creates a vulnerability, I think, within a food company, that if you are putting contaminated food out in the marketplace, there's a better chance now than ever before that you are going to get caught. And so you are motivated to up your game. Even if you thought you were doing good enough, you want to do better. You don't want to be that company that's associated with an outbreak. So are recalls increasing? Are outbreaks increasing? And why are they? That's the subject of some debate. But nevertheless, we see in the papers, the general public is seeing evidence of these issues occurring. And so companies are, even if not required, to test.
Sure.
They absolutely, from a reputational standpoint and just from a right thing to do standpoint, they've got to up their game. And when we see the availability of technology today, when we see that tools are out there that can help companies, I think we have to ask the question to companies who choose not to use them, why are you not? These things are possible today, and you're making a conscious decision to not do things that could be helpful. So I think there's that reputational kind of risk also.
Yeah, that was a bit of an eye-opener to me, right? Like understanding as a consumer and just general American, right? There's not a lot of regulatory requirement on the testing of food in general. The real lever is kind of being the buyers, larger groceries, industry, and business, as well as now the kind of new advancements in technology and traceability to kind of, we'll know if it was you because of our detection, right? And then the kind of, it's a good business practice, et cetera. And then the regulators are over here, right? Like that cadence, I didn't actually really appreciate ahead of this conversation. So, yeah.
Yeah, I mean, traceability is a very interesting concept in the medical world because, for example, a very common bacterium is called Staph aureus. There is a version of Staph aureus that's resistant to antibiotics, right? It turns out there's not just one. There are 7 different versions. So now the question is, can we get to the level where we can actually pick out which specific one is attacking you, the patient, and then, which specific antibiotic, or then trace it back and say, where did you get it from? Because, we looked into this place and that place, but they weren't the same strain. You know what I mean? So how can we leverage that as well? And I think the technology has the ability to do that because we can look for very specific proteins or molecules or whatever, all have a unique signature. And so we can actually get to that level.
And Adam, real quick, just how do we do it in the United States vis-a-vis globally? Like, is our food safer and better in the United States versus Europe and Asia and elsewhere? I mean, are there lessons to be learned by other countries just at a high level? I'm not, yeah.
Well, that's a good question. I mean, in terms of our food being safer, I'll defer to Jen on that one. But what I will say about overall performance of our healthcare system, it's pretty disappointing. If you look at the other 14 countries in the OECD, the US ranks at the bottom or next to the bottom for every single metric that they use. And that is a whole other discussion for another coffee with Ken. But the point is, we need to do better. And we need to detect better. We need to be out there being more proactive. Other countries that do better than we do, for example, they still do house calls in France. France is the #1 rated healthcare system in the world. We need to push things out to the home and get people out there. So anyway, you're getting me down a pathway.
No, that's exactly that. Interesting. And Jen, any thoughts on like lessons learned globally? Are there things, do you pay attention to what's happening in other countries and then that advice here domestically?
We have a global food supply chain. So bear in mind, especially when it comes to fresh fruits and vegetables, about half of our fresh fruits and vegetables that we eat are coming from outside the United States. And even as we look at processed foods, many of those ingredients, we just don't produce here in the US. We have to import them. So as a food safety professional, you have to be mindful of what's going on in the whole world because it is going to impact the US supply chain and US consumers. When I was in school and in the early part of my career, I often heard the US has the safest food supply in the world. And I kind of wondered at the time, like, how do you prove that? Because it's really complicated. Do we look just at the food itself and the safety of the food, which is kind of impossible? You can't test all food or you would not have any food left to eat. Do we look at public health outcomes? So as Adam was mentioning, the availability of healthcare, it may bias our interpretation. Like if people don't have access to healthcare when they get sick, say it is a foodborne illness, they may just like, I'm going to ride it out. I'm just going to deal with it. And then those things don't get measured. So we don't know the real burden of illness associated with foodborne disease. So how do you prove that you have the safest food supply in the world? I think it's tricky. And I kind of, at this point, I think it's imprudent for any country to make that assertion.
And it was fascinating preparing for today's conversation that the kind of thread I went down on just like food safety supply chain challenge the fact that we're talking about artificial intelligence, right? Like these are things that I wasn't inherently expecting that we would kind of, touch upon and dive in. So Matt, as you think more about the technology, right? Like when I get my meal later today for lunch, like can I just scan my food and make sure it's safe before I eat it? Like, are we getting there in 20 years and 2 years? Are you probably already doing that? I mean,
Yeah, so we are getting there. Um, we actually did some experiments where we actually, 3D printed a set of stuff to turn a phone into a spectrometer,
wow.
right? As it exists today. To really address that, there's some additional sensors that would have to be in a phone, but we're actually starting to find them showing up in phones. So yeah, we're getting there, right? We're getting to the point where you'd be able to do a lot of detection, by pointing your phone, and taking an image of it. I'll say that image will have a lot more data in it than what you would see with your eye, to find this stuff out. Well, I mean, we're a few years away from that. We're trying to address the issues right now in kind of where there's more concentrated quantities, right? Either in the food safety labs or at the food producers, or and through the supply chain, from the grower up to the retailer. One of the things that for us, that we really focus on is not necessarily on the hardware, right? We work with lots of different pieces of hardware. Again, your phone or spectrometers that are commercially available. For us, the value is in the software and the platform and the AI, and then just this amount of data, because it's right now we've been focused on the kind of the what is in there, right? Oh, it's the listeria, or there's no listeria, or it's E. coli, or it's salmonella. But we're really trying to build the platform in a way to help address the why, right? Or how is this happening, right? So we refer to that as spec AI or spectral, spectral intelligence. We use a lot of different internal names for it, but it's really all about turning that information or that data into information, and taking that information and gleaning intelligence out of it. Like, hey, gee, every time we get an outbreak in this facility, the average temperature and humidity the week before was, X and Y, or every time Bob Smith works in shipping and receiving, we seem to get a problem, or that it always seems to be coming, the incoming coming from the grower is, from this area, right? So to really help addressing kind of the root causes, so that, and I don't intend it to be, don't look at it as a punitive system. I look at it as hey, let's address and solve the root cause of the problem. And that's what we're trying to, our piece of that world, which is a small piece of the world, right? There's a lot of information that needs to be consolidated, but to help enable it, right? So that we can start to do a better job at prevention, because ultimately I want to have confidence in the food that I cook. I love to cook, and I would like to know that my baby carrots and my cucumbers are perfectly fine.
Wild. Adam, go ahead, please, Jen.
I think Matt brought up something interesting in looking at these correlations, because today their food industry does collect a lot of data, but often it's used for like the in the moment decisions. Is this okay? Is it not? And then we move on. And so to be able to look at the big picture, at the totality of data and how things are interacting with each other and possibly influencing each other, I think there's incredible power to that, and predictive capabilities associated with that. And it's not something at least for me, as an individual person, I can't wrap my head around that. But as we have software, as we have these tools now that can start to manage these different data sets and start to do these types of analyses, I see this as hopefully like the next horizon, the evolution of food safety, being able to use the data that by and large we already have, but use it better to make better decisions about things that have happened in the past, how we can change things in the future. And I hope that this is also attractive to younger generations. This ability to be more protective and not just make rote decisions, yes, no, but to really start using people's brains, having the analysis done by machines that can be done, and then like letting people think about the results and how are we going to do things differently. So I'm pretty excited about these opportunities to use bigger data sets.
Love that. That's amazing. And Adam, you talked a little bit about the kind of wound care. What are the kind of other applications to these advancements in technology that you're just kind of starting to kind of see and recognize?
Yeah, well, I mean, the fundamentals of the technology are that you can essentially train these AI models to identify whatever specific spectral signature you want. And so whenever you shine a light on something, it reflects a specific signature. So, pick what you want, basically. Like, what's the most important thing? Where do you want to go? And the concept could be, someone shows up sick in the emergency room, you don't know what's wrong with them. We can do even a multiple scan, right? If we can train it for certain bacteria or certain other things like high quantities of sugar in their blood or whatever, we can then train these models to do a screener. Remember Star Trek and the tricorder, right? So that's the dream we have at HyperSpectral. But the idea is, we want to show the value of doing that. And so I wanted to just for a second shift gears for a second, which is who's going to pay for all this, right? That is undetermined, particularly in the medical space. And so when you're, out front and you're leading with a new technology, the payers are reluctant. And in the healthcare system, it's like, oh, okay, well, that's new. Why should I pay for that? So we are very tuned into the fact of showing the value, like we're reducing the cost of care, we're making outcomes better, measuring those things right up front as we get started on this journey, and then showing the payers and the practitioners and the patients why there's value here. And because if we don't do that, you end up spinning your wheels for a long time. So
Got it.
pay attention.
So just to kind of close out, look, I sit here in Washington, and part of the themes of Coffee with Ken over the years has always been kind of this call to action with government, right? Like, what could government be doing better? And we're approaching an inauguration of a new administration that's a little focused on disruption, and the new appointee for the FDA and Health and Human Services, right? It seems like an opportunity for kind of let's try new things and gut check the system, and might be an opportunity for stress testing things. Is there any kind of advice that you have for folks in Washington, or suggestions of things that maybe they could prioritize or focus on as it relates to kind of food safety, things that maybe stressed you out or you just didn't appreciate in years past? Because it kind of feels like things are on the table for new approaches. So
yeah, I think for me it's encouraging the government to encourage new approaches and not be punitive. So if people are going to look for issues, if you really want people to find their vulnerabilities, you can't encourage them to find vulnerabilities, and when they find them, then penalize them. So I think we need to shift that mindset where as long as you address the issue that you found, you can move on without penalty.
Right. Adam?
Yeah, I mean, sort of from the medical device space, it's really encouraging more of a benefit risk balanced approach. And right now, regulators are extremely focused on risk almost exclusively. And so the concept that our product, for example, you're shining light on somebody, the risk is nil. It's essentially, it's in the regulatory language, it's minimal, but we know you can't hurt somebody. So if there's any benefit to be had, that is something that patients and physicians should enjoy using. So it should be made available. And, shifting that concept, getting out of that box to really say there's benefit here and the risk is so low, let's make it available. So that's my personal advice. So there.
Perfect. And Matt, I don't know what administration was in office in 1892, but I'm sure there's some anecdote between then and today we can glean.
Well, that's a really good question. I used to really enjoy U.S. history, but at some point I
was it Garfield?
I lost my memory of all of the presidents. I used to be able to recite them up and through, the first George Bush. Then I graduated college, and I can't recite them anymore. For me, it kind of echoes both Jen and Adams. Right now, we have a stick system. So to quote a president from a long time, let's have both a stick and a carrot, right? Walk softly, carry a big stick, but you have a carrot out there to enjoy it. So let's really focus on incenting the adoption and the development of these technologies. Right? There's a wealth of technology that gets through to a certain level in universities or other places that are focused on research, and then it stagnates. Right? It goes nowhere, which is really shameful.
Yeah.
At the same time, you've also got to focus on technologies that solve a real problem. So, because again, the world is littered with awesome technologies that don't actually solve a business problem or a societal problem, right?
Yeah.
Really, really cool, but they don't actually solve a problem.
Yeah.
So, programs that incent, somebody to find the technologies and solve real problems, which is what entrepreneurs do, right? That's what most entrepreneurs spend their lives doing. Hey, this is a really cool technology. Let's find a way. Does it solve a problem? Okay, let me marry it, try to grow a business. So incenting that, I think, is really, really important. And that's not just, say, in food safety or human health, but just across the board, right? Let's get that technology and those solutions unlocked, and let's enable those entrepreneurs out there who want to marry the business problem to the technology that exists.
Well, I'm so grateful to Jen, Adam, Matt. Appreciate all of you taking the time to be on here. It's such a fascinating topic. To Jen's point, we all eat. This is something we are dealing with on a daily basis. But when you take a step back and think about the kind of magnitude of our food system, from the supply chain side of it to AI and innovation and technology and health and wellness, and also these innovations and what they mean for broader applicability and the need for talent in these sectors, right? I don't know how many young people are thinking about, I want to be in food safety and innovation and all this, even though it impacts everybody daily. It is another kind of, I think, interesting call to action as well. Just like there's cool things happening, and I think you all three collectively have made this a fun sector for more people to get involved in. So grateful for you guys being here today.
Thank you.
Thank you very much.
Yeah, and listen, everybody tuning in. Thanks for watching. Whether it's this episode or past episodes or signing up for future ones, you can just visit us at coffeewithken.com. Until next time, thanks so much, everyone.
Thanks a lot. You take care.
Thank you.